In this question, we know 21.57 grams of sodium amide reacting with 11.27 grams of nitrous oxide, and forming the desired product, sodium amide. So first we need to find out what is the limiting reactant. In order to solve this problem, let's recall what we already learned previously in lecture 22. So the guidelines for solving such a problem related with the limiting reactant, theoretical, and percent yield. So they are given in lecture 22. And this is the slide number 7 in lecture 22. Guidelines number 1, we need to convert the mass of mole amount of each reactant to the mole amount of the desired product. Let's go back to our question, which means we need to convert those mass of reactants to the moles of the desired product. Let's start with the first one. That's 21.57 grams of NaNH2. So we need to convert that from grams using the molar mass, converting from 39.01 grams for 1 mole of NaNH2. On the bottom, the same thing, NaNH2. Grams and grams are cancelled. Now we need to convert from moles of NaNH2 to moles of NaN3. Now, what's the ratio of the moles of the two? We have to go back to the balance equation. 2 moles of sodium amide yields 1 mole of sodium azide. And now use a calculator. Start from 21.57. 21.57 divided by 39.01. Further divided by 2. And now, since in the question the fewest number of sig figs, that is 4. So therefore we'll keep 0.2765 moles of NaN3. Now let's work on the other reactant, 11.27 grams N2O. we convert from the grams to the moles of N2O using the molar mass of N2O, which is 44.01 grams of N2O for 1 mole of N2O. Grams N2O, grams N2O are cancelled. And now we convert from 1 mole of N2O, if you look at this balance equation right here, to also 1 mole of sodium azide. And now moles N2O are cancelled. Let's use the calculator again. We start with 11.27. Divided by 44.01. That's it, because the rest of them are just all ones, whether it's a multiplication or division. And the answer should be, again, we keep 4 sig figs, 0.2561 moles of NaN3. So now we'll compare the two mole values for the desired product NaN3. See which one is smaller. Of course, this one is smaller. So therefore, the reactant that yields this smaller number of moles of the desired product, that is the limiting reactant. Therefore, N2O should be the limiting reactant. Yeah, as you can see, before I made this video, I already worked on this problem. So I already entered my answer. Therefore, N2O is the correct answer. So which means N2O is the limiting reagent. Now the second question is how much sodium azide is produced. So we already know the number of moles of the desired product. We just simply convert from the number of moles to grams of sodium azide using the molar mass of sodium azide. So 0.2561 moles, converting from moles to the grams using the molar mass, 65.01 grams. Moles and moles are cancelled. Let's do that again using the calculator. 0.2561 times 65.01 should give us 16.65 grams, because we need to keep 4 sig figs. And the desired product, sodium azide. So you key in that number, 16.65, and submit, and the system should give you the credit showing this value is correct. So that's how you solve problems like this. Again, if you forget the strategy, You just follow those rules right here. That's it for this question.